Hi guys, my name's Arvindh. Welcome to 6th grade math with all STEM. We will be discussing ratios and proportional relationships. This video covers the basics of ratios, relationships between all types of numbers, plotting numbers on the number line, and understanding relationships between numbers in word problems. As always, our videos consist between 8 to 15 review questions. Each one is timestamped in the description box. If you get a question right, feel free to skip to the next timestamp. Otherwise, go ahead and watch the explanation after each question. All right, let's get into the first question. Okay guys, so here are the topics we'll be focusing on today. So first, we're going to understand the concept of a ratio through a couple problems. Next, we're going to see how ratios can be expressed as equivalent unit ratios. Then we'll use ratio reasoning with equivalent whole number ratios. And finally, we'll use ratio reasoning to solve real-world problems. So let's start with our first question. So Troy is working on puzzles. He noticed that he completes puzzles at a steady pace. He recorded the number of puzzles he solved and how many hours it took him in the table on the bottom. So there's two parts to this question. So first is to write as many ratios from the table as you can and identify which ratios have the same multiplicative relationships. Next, we need to find out how many multiplicative relationships can be seen in the table. So pause the video here and solve the problem. And I will show the answer in 3, 2, 1. Okay, so for A, it is 2 to 6, 4 to 12, 1 to 3, 2 to 4, 6 to 12, and 1 to 2. Those are all of your possible ratios. And for B, when comparing puzzles to hours, we can see that the ratio is 2 to 6 and 4 to 12, and we can simplify them too. When comparing hours to puzzles, the ratios flip, so it becomes 6 to 2 and 12 to 4. If you got these answers right, feel free to go to the next question. If you got them wrong, or if you just want to review, hang around and I'll explain these questions. Okay, so let's first start with part A. So the first ratio we can identify is 2 to 6. And we can identify this because that is the first number in our puzzles column, the first number in our hours column. So 2 to 6 makes sense. Now, using that same methodology, we can identify 4 to 12. And those can be the two ratios that we start out with. Now we can also use ratios in the same boxes. So 6 to 12 also counts. And in that case, 2 to 4 also counts. But if you can tell, there's actually 6 total. So what does that mean? We can actually simplify these two. We can simplify these ratios. So 4 to 12 is actually also, is actually 1 to 3. And 2 to 6 is also 1 to 3. 2 to 4 is 1 to 2. And 6 to 12 is also 1 to 2. So we can have a total of 6 different ratios. And I crossed out these two because they have duplicates of themselves. So it's unnecessary to have 2 of the same ratios. Okay? So the total ratios we have is 6, and that adds up. Now let's go to B. So how can these multiplicative relationships be seen in the table? So basically, I can find these ratios by just looking at the corresponding section. So what I mean by that is this puzzles section has the numbers 2 and 4. So let me erase this. because it's kind of looking hard to see. So the puzzle section has 2 and 4. And the hours section has 6 and 12. Basically, because these are in separate sections, we can compare the sections to each other, and we can also compare them to themselves. Essentially, puzzles to hours, we can see 2 to 6, and hours to puzzles, we can see 6 to 2. And the same thing with 4 to 12. All right, let's go to the second question. So Gabriella is doing a project for her math class that involves the number of students in her grade. There are 240 students in 6th grade and 12 teachers. She needs to figure out A, what are the unit ratios that compare the teachers to students and vice versa, and B, how many students are there per teacher and vice versa. So quickly, let me explain the vice versa part. Basically, for A, we need to find out how many teachers there are to students. Hold on. Yeah, how many teachers there are for students and how many students there are per teacher. And for B, we need to find out how many students there are per teacher and how many teachers there are per students. All right, so pause this video now, and in a few seconds, I will show the answer. Okay? 3, 2, 1. Okay, for A, our answer is when using the notation teachers to students, we get 12 to 240 or 1 to 20. When using students to teachers, we get 240 to 12 or 20 to 1. And in B, the ratio in part A means that for every teacher, there are 20 students. The second ratio says that for 20 students, there's 1 teacher. So let me explain this. If you got this question right, feel free to skip to the next one with the timestamp, or if you got it wrong, hang out and I will explain the answer. All right, so for A, we got 12 to 240. So first, let's identify these terms in the problem. So there are 240 students and 12 teachers. So S is students and T is teacher. So we need to find the ratio that compares teachers to students. That is going to be teachers to students, which is 12 to 240. So that is our first part. And now we need to find the ratio that compares students to teachers. So that's going to be 240 to 12. Okay? So that is how we get our answer for A. And to simplify, it is, like written here, is 20 to 1. For this ratio. For this ratio, it's going to be 1 to 20. Okay? Now, for the second part. The first ratio in part A means that for every teacher, there are... Oh, my bad, not this one. For this one. For every one teacher, there are 20 students. And the second ratio is saying that for every 20 students, there's one teacher. So what is the takeaway from this? Essentially, ratios are reversible. So if we have 5 dogs to 1 cat, that means for every 5 dogs, there's 1 cat. That also means for every 1 cat, there are 5 dogs. Ratios are irreversible. So no matter how the problem is given, make sure that you read it properly so you give the right answer. Because although 1 to 20 and 20 to 1 could mean the same thing, without your units, they can mean completely different things. All right, let's do our third problem. So, Sharpay is buying audiobooks from onlinelisten.com. The website sells its audiobooks at the same rate and are currently advertising 3 audiobooks for $39. She needs to figure out A, how much would 7 audiobooks cost, and B, how many audiobooks could be purchased with $54. Pause the video now and solve it, and in a few seconds I will reveal the answer. 3, 2, 1. So our answer for A is that if 3 books were $39, we know 1 book equals $13. Therefore, 7 books is 7 times 13, which equals $91. And B, $54 over 13 equals about $4.15, which will get you 4 books with change. So, if you got this question right, feel free to skip to question 4. But if you got it wrong or you just want to review, hang out and I'll explain the answer. So let's do A. So 3 audiobooks will get you $39. Well, $39 will get you 3 audiobooks. So buying 3 audiobooks will cost you $39. So how much would 7 audiobooks cost? We can use the butterfly method for this. Okay? So quickly let me review the butterfly method. So we have, let's say, 2 dogs for 4 cats is X amount of dogs, or unknown. X represents unknown number of dogs over 8 cats. Okay? What we can do is that first we want to just take away our units. And we do this thing called cross multiplying. So essentially, this is also called the butterfly method. What we cross multiply, so we cross multiply 8 and 2, because that's across from each other. So that gets us 16. And then we multiply 4 and x, which gets us 4x. Now we have to divide over our 4. So then we'll get 4 equals x. So there will be 4 dogs for 8 cats. That's how we can cross multiply. So here we can actually cross multiply. Or we can do it an easier way. I'm going to do it the easier way just to save time. So if 3 books cost $39, that means, like where I did here, how I divided, let's divide here. What's 39 over 3? 13. That means 1 audiobook costs $13. So we want to figure out how much would 7 audiobooks cost. So simply, we do 13 times 7, which is 91. So 7 audiobooks would cost $91. Now, how many books could be purchased with $54? Since we found out our rate for 1 audiobook, let's just divide 54 by 13. And like listed here, it's going to give you about $4.15 per book. And note that this is an about. This answer is listed with the word about, meaning that the true answer is probably like 4.151396 whatever. It's going to go on forever, but that's not how we write money. We always want to round it to the hundreds place. So here it would just be rounded to 4.15. So you will buy basically 4.15 books. But you can't really buy 0.15 of a book, right? Therefore, you can only buy 4 books. But that 0.15 that you can get with money, since you can't actually buy 1/15 of a book, that extra money is what you will get as change. So whenever you get a decimal when you're buying whole objects, you always say with change when you're talking about money. All right? Okay, Chad is planning a class event with his teacher. If 44% of the students in Chad's class like chocolate ice cream, then how many students are in his class if 11 like chocolate ice cream? How many in his class don't like chocolate ice cream? All right, so we haven't dealt with percents before, but here we are. This is our introduction to percents in this standard. So let's pause right here and solve this problem. In a few seconds, I'll show your answer. Ready? 3, 2, 1. So, answer. Using some equations and arithmetic, we can conclude that there are 25 people in Chad's class. Since 11 like chocolate ice cream, we need to subtract that from 25 to find the difference. This means 14 students don't like chocolate ice cream. So if you understood this, skip to the next question, and if you didn't, I'll explain the answer now. So 44% of the students in Chad's class, students equals 44% who like chocolate. That means don't like chocolate. Okay? 11 like chocolate ice cream. Okay? So, if 11 is 44%, how much is 100%? Okay? So, let's do some cross multiplication like I showed in the last problem. This is going to get 1100 or 1100 equals 44. Okay? So let me just put this in my calculator. Oh, it equals 44x. My bad. Let me put this in my calculator. So x is equal to 25. So there are 25 total students in the class. So for B to find how many don't like, simply we just have to subtract the number of people who like chocolate from the total number of people. And we get, 14. We get 14. So 14 people don't like chocolate ice cream, and 11 people like chocolate ice cream. All right, let's do the fifth problem. So, Taylor recorded the number of fish in an aquarium. She used a filled-in circle for guppies and an open circle for goldfish. Below is her recorded count. So this little graph here is her recorded count. So there are two parts. So first, what is the ratios of guppies to goldfish? Second, what is the ratio of guppies to all fish? Pause the video now, and in a few seconds, I'll go over the answer. Ready? 3, 2, 1. So for the first part, the ratio is 2 to 3, and for the second part, the simplified answer is 2 to 5. And just a note, make sure that you always give the simplified answer. So 6 to 15 was the answer that you should have gotten before you simplified it. Since simplification is the right answer on any test or EOG or basically any test that you ever take, the answer will always need to be simplified unless stated otherwise. Anyways, let's get right into the problem. So, filled in circle. Oh my gosh, I never select pen. Okay, filled in circle is guppies. So, these ones are the guppies. And the open circle is goldfish. So, these are the goldfish. And notice how I just grouped them. In my head, I always like to group objects because, I don't know, it's just nicer to see groups of objects, you know? Like, it just makes it more neater to see. But anyways, that's just a good strategy, is to group objects so that you can count it better too. Because if you have 3 dogs and 4 cats in one group and you identify 5 different groups, you can easily find the total number quickly instead of counting each individual one. So anyways, there are 6 guppies, because 2, 4, 6, and 3, 6, 9. 9 goldfish. Okay. So what is the ratios of guppies to goldfish? That's 6 to 9, which is 2 to 3. So that is how I got the first answer. And the second answer, guppies to all fish. So the guppies number is 6. So 6 has to be our starting number. All fish, we just have to add both of our fish populations which will get us a total of 15. So our total number is 15. So our ratio for guppies to all fish is going to be 6 to 15, which is 2 to 5. And that's what we got here. All right, let's do our sixth problem. So there are two separate problems in this one because I figured that these were two simple ones, and it's just a review of pretty much everything that we've done here. So I compiled them into one big problem, if that makes any sense. So problem A, on a bicycle, Zeke can travel 20 miles in 4 hours. What are the unit ratios in this situation? Recall the processes that we used in the previous problems to help you with this one. Okay, and problem B, Kelsey is selling candy bars and she needs to figure out the unit ratio for selling 4 candy bars at $3. Okay, and recall the unit ratio practice that we did a couple problems earlier. Okay, pause the video here and solve these two problems and check your answers when I reveal them in a few seconds. Ready? 3, 2, 1. So for the first problem, in miles to hours notation, it would be 5 to 1, and in hours to miles notation, it would be 1 to 5. For number B, For letter B, it would be 1 to 0.75, or 1 candy bar equals 75 cents. So if you got this question right, feel free to skip on, and if you didn't, or you just want to review, I will explain it right now. So for problem A, let's identify our units. So 20 miles in 4 hours. So pretty much that is our ratio right there. 20 miles in 4 hours. Let's divide both sides by 4. Got 5 miles in 1 hour. There is our ratio. In miles to hours notation, because miles is first, it'd be 5 miles to 1 hour. And now when we write it in hours to miles, we're just going to switch these over, which is going to give us 1 hour to 5 miles. So now let's do second problem. So Kelsey needs to find the unit ratio for selling 4 candy bars at $3. So whenever people want unit ratios for purchasing something, they don't want to know how much can $1 get them. They want to know how much do they need to pay to buy one of those things. At least that's what you can infer always, unless it states otherwise. So we need to find pretty much how much 1 candy bar will cost. So if we just use some simple division, we know that 4 gets us 3. So $3 gets us 4. So buying 4 makes us spend 3. So buying 1 makes us spend how much? $4 for 3 equals 1 for how much? Let's do our butterfly method. 4x equals 3. X equals 3/4. X equals 3/4. So 3/4 out of 100 is what? Or 3/4 out of 1 is what? 0.75. So our ratio is going to be 1 to 0.75, or 1 candy bar is 75 cents. And that is it for problem 6. All right, let's do problem number 7. So Ryan is directing a musical this semester. He needs to buy 40 scripts for his class. On the website he's purchasing from, a group of 9 scripts is $10. He needs to make these purchases quickly. He needs to know, first, how many groups will he need to purchase? B, how many extra scripts are left, and how many do these extras cost? All right, pause the video here and try to solve this on your own. Once you get your answer, unpause and I'll reveal the answer. Ready? 3, 2, 1. Ryan needs to purchase 5 groups of scripts for the first problem, and there are 5 left over, and they cost around $5.56 total. So let's solve these. So for the first one, Ryan will need to purchase 5 groups of scripts. So he needs to buy 40, and he can buy 9 each. So we need to figure out how many groups of each. Oh, how many groups of 9 can fit into 40? What does that remind you of? Division. Let's divide 40 by 9. So how many times can 9 go into 40? Let's think. 4. Ooh, and we have 4 left over. Yikes, poor people won't get a script. Hold on. We know how to decimal divide, don't we? How many times can 9 go into 40? Again. 4. And this is going to go on forever. So it's going to be 4.4 repeating. What will we do? Simply, we can just buy another one. Ryan can just buy another group. So he can buy 5 groups. So when he buys 5 groups, that's going to mean 9 times 5, which is 45. So how many extra scripts will we have? He will have 5 extra scripts. And, I almost forgot to answer the first one. Yes, he will need to buy 5 groups of scripts. Now, I accidentally jumped ahead to the second one, but yes, there are 5 left over because he only needs to buy 40, not 45. So how do we figure out how much they each cost? So if 9 is $10, then how much do these extra 5 cost? Let's put it in our little butterfly setup. Butterfly multiplication is very useful, if you couldn't tell. But anyways, let's set this up. So 9 scripts cost $10. So 5 scripts cost how many? Let's do our butterfly multiplication. 9x equals 50. X equals 50 over 9. Let's put that in the calculator. You could do this by hand, and it would work. So x equals approximately, that is the approximately equals sign. These two squiggly lines approximately equals 5.556. But when we have to round to, as I like to say, money notation, that's going to get us $5.56 for these total 5 scripts. And that was problem 7. Yay, you guys made it to the last problem, problem number 8. Let's go ahead and start this. So, Coach Bolton is making trail mix before his team's big game. In the trail mix, the ratio of cups to peanuts to cups of chocolate candies is 3-2. So there are 2 problems in this. So first, how many cups of chocolate candies would be needed for 9 cups of peanuts? And next, how much trail mix would be created using this ratio, and how much would each person get on Coach Bolton's 9-person team? So take a second and pause this and solve the video. And when you're done, unpause and I'll reveal the answer for you to check. Ready? 3, 2, 1. So 6 cups of chocolate goes to 9 cups of peanuts, and 5 total cups of trail mix will be created in total. Okay, so let's do the first part. So how many cups of chocolate candies are we needed for 9 cups of peanuts? So our ratio is 3 cups of peanuts for 2 cups of chocolate is equal to 9 cups of peanuts for how many? So let's do our butterfly multiplication. So we get 3x equals 18 and x equals 6. So 6 cups of chocolate for 9 cups of peanuts. Okay? And now let's do our second part. So if we add both of these amounts together, we get 5. Because 3 plus 2 equals 5. So we're going to get 5 total cups of trail mix. Oh, looks like I didn't solve the second part. Okay, how much would each person get on Coach Bolton's 9-person team? So we have 5 cups in total for 9 people. So we need to divide 5 by 9. Okay? Let's do this. So how many times can 9 go into 50? 5 times. So it's just going to be repeating 0.55. So we can say, so we know it's total 5 cups of trail mix because we just solved that here. And for the second part, we can say about half a cup. Okay? Great job, guys, for making it through all these problems. If you want to review certain topics after this video, we have a link to further reference box in our description box down below, along with all of our other questions. On this page, we have a link for each question so that you can dive deeper into the more challenging ones. These are great for extra practice. I hope that this was a good review of these topics. Like I said at the beginning, make sure to check out our links for further reference for more practice on these topics. Did these questions help you out? Do you have any more questions? Let us know in the comments down below. If this video was helpful, please like, share, and subscribe. Thank you, and I hope to see you in the next video. Bye.